In this lab, there are a few items you'll need. You'll need a hot plate, but we're not going to use the heating setting. We're only going to use the stir setting. In order to heat our sample, we're still using a heating mantle and power supply. We have a stir bar that we're going to add to our round bottom flask. We also have some clamps to hold our condenser up, as well as a blue clamp to hold the condenser to our round bottom flask. We also have some pre-weighed Stilbene that we'll put into the round bottom flask. And then we also have some vacuum grease, so we'll apply that to the condenser joint before placing it into the round bottom flask. And then finally we have some hoses that we can use to connect to the condenser and our water tap. So I've set the round bottom flask in the heating mantle, and the heating mantle is on top of the hot plate. Now remember, we're only going to use the hot plate for our stir function. So in the round bottom flask, I've already placed the stir bar in there. So again, we're only using the hot plate for the stir function. I've also connected the heating mantle to the power supply and I've plugged it in. In the next step, we're going to add our Stilbene to the round bottom flask. So this has been pre-weighed. So there's about 0.5 grams of Stilbene in here. And we're just simply going to pour this into the round bottom flask. And then in the next step, we're going to measure out 10 milliliters of ethanol, which is in the brown bottle down below. Now we're going to add our measured 10 milliliters of ethanol to the round bottom flask. So in the flask, we have our Stilbene, as well as a stir bar and our solvent ethanol. In this next step, we're going to set up our condenser. So the condenser is actually going to sit on top of the round bottom flask. I recommend putting the hoses on first before placing the condenser in the round bottom flask. This will be a little bit easier. So the bottom hose is going to connect to the water tap in the back of the fume hood, and the top hose will be the drain. We also want to remember to put some vacuum grease around the bottom joint so that we prevent the glassware from sticking together if a vacuum forms. Here you can see I've set up the condenser using a clamp on a ring stand, so it will stay upright during the reflux. Now, in order to keep the two pieces of glassware firmly together, I'm going to use a clamp. Now in the next step, I'm going to connect the bottom hose to the water supply and the top hose will go down the sink. Here you can see that the hoses are now connected to their proper places. The bottom hose is connected to the water faucet in the back, and the top hose is going down the sink. So now we can start heating and stirring. So now I'm going to turn on the stir setting on the hot plate, as well as the heat setting on the power supply. So I'm going to set the stir setting to sort of a middle range, around 6 or 7. And then I will turn up the heat on the power supply to about a 6. And we can adjust the heat if needed. And this is what our solution will look like in the round bottom flask after we've turned on the stir bar and the heat. So remember that the condenser has two separate portions. It has an inner tube and an outer tube. So the inner tube is completely separate from the outer tube. Now water is going to come in from the bottom and it's going to wrap around the inner tube and then exit out the top. And this will condense any vapors. So here we can start to see some steam or vapors forming from our solvent, and they're recondensing back into the round bottom flask. So we're not losing any of our solvent throughout this process. It's just rising up and cooling down and then falling back into the round bottom flask. Once the majority of the Stilbene has dissolved in the solvent, we're going to add 1.2 milliliters of concentrated aqueous hydrobromic acid, which has a slight yellow color to it. We're going to add it from the top of the condenser and it will just drip down into our round bottom flask. So in order to do this, we're going to use a pipette and a pipette bulb. So we'll need to put the pipette bulb on top of the pipette to start, and then we can use it to deliver our solution. So here I'm going to add the solution through the top of the condenser, and you'll see it drip down into the round bottom flask as you deliver the hydrobromic acid. In this next step, we're going to add 0.8 milliliters of 30% hydrogen peroxide. We're going to do this the same way we did before with a pipette, a clean pipette, and we're going to add this through the top of the condenser. But what I wanted to show you was the color change that occurs during this process. So I'm not going to show you the addition of hydrogen peroxide. Instead, I'm going to move my camera down to the round bottom flask below, and we're just going to watch for any color change that occurs after the addition of hydrogen peroxide. So here you might notice a yellow color starting to form. I'm adding the hydrogen peroxide very slowly. So upon each addition of a droplet of hydrogen peroxide, you're going to see a slight color change. Now you do want to add the hydrogen peroxide very slowly. If you add it all at once, it can cause an intense reaction. So we don't want that to occur. So now you can see a dark orange, almost red color within the round bottom flask. So we've added all of the hydrogen peroxide, and now we're just going to wait until this color goes away, and then we'll know that the reaction is complete. So it looks like all of the yellow-orange color has gone away. So that means that the reaction is complete. So in the next step, we're going to remove our flask from the heating mantle, and we're going to let it cool to room temperature. And then we'll adjust the pH of our solution. In this next step, I'm going to add sodium bicarbonate to the solution that I just produced. And I'm going to use pH paper to track the pH of my solution. So I want my solution to be between 5 to 7. So we want the pH paper to be orange, yellow, or a tiny bit green. So I'm first going to test the pH of my solution before the addition of any concentrated sodium bicarbonate, just to see where we're at. So I'm grabbing a piece of pH paper with tweezers so that I don't contaminate the pH paper with anything that might be on my gloves. Then I'm using a glass stir rod and dipping it, and then I'm just placing a drop of solution onto the pH paper. So you can see that this is quite acidic. It's very red. So we're going to add our sodium bicarbonate to make sure that we are within a range of 5 to 7. So we're trying to neutralize our solution. So let's add some concentrated sodium bicarbonate to our solution. And I'm just going to add a few drops at first and see what kind of effect that has on the pH. Next, I'm going to stir my sample so that the sodium bicarbonate evenly mixes. And then I'm going to test the pH again and see if it has changed. So I'm going to use my glass stir rod again, but I'm just going to wipe it off really quickly so that I don't contaminate my solution. All right, it's nice and clean now. I'm going to dip it in the solution again and see what the pH is. Okay, so it looks like we're still very acidic. So what I'm going to do is save you the time and effort of watching me go through this process again. I did end up having to add quite a bit of concentrated sodium bicarbonate. So here you can see I've skipped ahead and I have a lot of pieces of pH paper sitting over there. So it did take me quite a while to find the right amount of sodium bicarbonate. So I'm just going to add a few more drops and then test the pH again. And hopefully, after many trials here, we'll finally have a neutral solution. Okay, so the pH paper looks a little red still. Okay, so I'm going to try this again. Alright, it's still red, so we're going to add more sodium bicarbonate. And you can tell I got a little careless with the amount that I was adding because I had added quite a bit at this point. Alright, so now we're going to test the pH again, and let's see if we finally have a neutral solution. Alright, so it looks like we have a yellow-green color here, which means our solution is neutral. Alright, so now we can move on to the next step. In this next step, we're going to place our round bottom flask into an ice bath. So I had formed an ice bath earlier in that big plastic bucket, but I transferred the ice bath to a beaker so that my round bottom flask wouldn't fall over into the ice. So we're just going to let this sit for a while in order to bring more product out of solution. Next, we're going to use vacuum filtration. So this is our setup for vacuum filtration. We have an Erlenmeyer flask in the middle that's connected to a hose that's connected to another Erlenmeyer flask with a side arm. And then the other hose is connected to our vacuum line, which is yellow. We also have a Buchner funnel sitting on top of our Erlenmeyer flask to the left. It has a rubber stopper that holds it in place. And there's a piece of filter paper covering the holes on the top. So the filter paper originally looked like this, but I did put some water on it to hold it down so that the edges weren't sticking up. So vacuum filtration will allow us to separate the solid from any liquid that's left. And here I'm just testing the vacuum line to make sure that I can hear the vacuum going. So I'm going to turn it on by turning it to the left. All right, and then I can also test this by spraying some water and seeing if the system sucks the water out, and it looks like it did. So the water went right through, so that's good. So in our next step, we're just going to carefully pour our solution from our round bottom flask into the Buchner funnel. And you want to try to aim for the middle of the filter paper so that the product doesn't slip over the edge of the filter paper. So here you can see that the liquid is getting sucked through, but the solid should remain on the filter paper. Now there is some solid left in my round bottom flask, so I'm just going to use some cold water to rinse that out. So here's what our final product looks like. There's some white solid in there, and I'm just going to let this sit and dry further. You can also break up the solid or any chunks with a spatula if you need to. That will increase the surface area. Next, we're going to pre-weigh a beaker, and then we're going to transfer our dry solid into the beaker. So my solid has been sitting in the vacuum filtration system for a while, so I'm assuming it's dry. If I had more time, I would have let it sit overnight to dry, but that was not the case. So I'm going to use a spatula to gently scrape my sample into this beaker, and then I will weigh it. So when you're scraping the filter paper, try not to scrape too hard, otherwise you'll end up with filter paper in your product, which we don't want. Also, you'll just want to be careful not to spill any of your product. I noticed I spilled a couple of pieces there off to the side, so I'm just going to take note of that, and that can account for some of the error in my mass. So once I'm done transferring all of my product into this pre-weighed beaker, I'm then going to weigh everything together to get my total mass, and then I'll subtract the mass of the empty beaker to find the mass of my product. Now, according to your procedure document, the typical yield for this reaction is about 90%. So if you want to compare our yield to that yield, we'll see how well we did. You can also replace the 30% hydrogen peroxide that we used with 3% hydrogen peroxide that you would find at a drugstore, but the yield reduces to 30 to 35%. So here we did use 30% hydrogen peroxide, so we should expect a yield of around 90%. So here you can see I'm just messing with the balance a bit, trying to make sure it's zeroed properly. And I've got my final mass. So next, you're going to analyze how well we did. We can further analyze our final sample using a melting point range. So we're going to measure the melting point range of our product. I've already set up the capillary tube with some of our product, and I'm just going to preheat the Digimelt up to a fairly high temperature. I encourage you to look up the melting point of the product, which should be 1,2-dibromo, 1,2-diphenylethane, or also called dibromostilbene. All right, so my ramp rate is 2 degrees Celsius per minute, and we'll just stop at about 250 degrees Celsius, and we'll see what our melting point is. So I'm placing my sample into the Digimelt, and the temperature right now is around 224.4. Now right away, some of the sample does melt a little, although we haven't formed a liquid quite yet. And then we'll just wait and see what the melting point range is for our final compound. So I'm starting to notice some changes in the solid that's in the melting point tube or capillary tube, and that means I want to start keeping an eye out for the initial melting point of the compound and write that down. And then once everything has melted, we'll record the final melting points. And then we want to compare this to our expected product's melting point range and see, do we have a pure product or do we maybe have some impurities? And now you can answer all of the post-lab questions. If you have any questions, just let me know.